another presentation. Our next speaker is Vyacheslav Moskvin, Learning to Break a Factory. Vyacheslav, over to you. Yes, hello everyone. Hi, and welcome to this presentation slash workshop. It's a pleasure to see all of you here today. Let me start by discussing what lies ahead for all of us today and tomorrow. As promised, today I'll be talking about the CL server and the technology and how it can be approached and what results can be obtained. And I will also discuss today how this theory can be applied in practice if you are running critical infrastructure. Then you have to learn to be responsible about it. There will be a deep dive into the PLC. I will explain how this device works. And tomorrow, we will start looking into reverse engineering. We will learn how to obtain the firmware. Not always. This can be done in just one click at the vendor's website. There are many different scenarios there. And then we'll have to see how to start parsing it, how to start analyzing it, because sometimes it's just binary code that runs on bare metal. And we will also see the first steps in bare metal firmware reverse engineering. If you don't have any prior experience, I will be making several demonstrations. Today there will be a demo for the OPC server, and tomorrow there will be a demo for the first steps in bare metal. And if time permits, we will also organize a Q&A session. Here on the slide you can see our timetable for today and tomorrow. So please put all of this in your diaries or rely on your memory, or you can always watch the videos again. So today we have 2 hours, 4 to 5 Moscow time and 7 to 8 Moscow time, and tomorrow again 2 sessions between 4 and 8 p.m. and 6 p.m. and 9 to 8 p.m. Moscow time. Okay, let's get started. And we begin with the OPC server. As I have already explained, the OPC server can be a border node between the IT network and another network. It can be somewhere on the network. It can be not just a node, but rather a code that runs on a machine. Well, since this is a machine that in most cases will be running Linux, all your usual tricks that you use for pen testing will work. So it's the usual pen test stuff. You'll be able to use vulnerabilities in the ICS software of the OPC server. And you can also abuse the features of the ICS software. Since the OPC server reads and writes variables related to the process, that's why abuse is possible. And you will be able to get additional information, or the data that is transmitted somewhere will be distorted, or in the rarest case, the OPC server, after rewriting some variables, will ask the PLC to rewrite them too. And this is the most critical thing that we can initiate. Let's talk about this technology. OPC is a family of protocols. It includes OPC-DA, HDA, historical data access, UA, unified access, and several other protocols. We need OPC for the reasons that we touched upon yesterday. Maybe at your factory you have a PLC from one vendor and hardware from a different vendor. The SCADA system comes from yet a third party. Maybe it's not a PLC vendor, but some third party's SCADA. And we were saying that management also needs the access to this data, and probably the information that collects that kind of data will come from yet another provider. So how do you marry all these different sources of data if they are associated with various vendors? We know that many PLCs often have their own proprietary protocols. You can't find their descriptions anywhere. And, it makes it rather challenging. OPC is intended to solve this problem. The OPC server understands the protocols. The server may be developed by one vendor. It may be supporting different software. OPC absorbs all the different protocols and stores them in the database, and then converts them basically into the RPC protocol. Let's remind ourselves of the scheme that we saw yesterday. Over here is the OPC server. Okay, let me show it to you. And it can be the border node between the corporate network and the SCADA network. In order to enter the SCADA network, perhaps you will have to hack this server, or you will have to get access to the server variables so that you can rewrite them. And then you will be able to interfere with the production process. Now let's take a look at two most important protocols in the family, OPC-DA and OPC-UA. OPC-DA historically is the first protocol in the series. Its first version came out in 1996. It's based on Microsoft DCOM. This technology today is not as widely used as it was back in those days, but we still see it around. And OPC-DA, although it was developed a long time ago, still, in real terms, it is still very popular. In most real assets with which we worked, we encountered OPC-DA. And since this is based on Microsoft DCOM, it also uses authentication provided by Windows. OPC-UA is a newer version of the protocol. It was released in 2006. Well, actually, it's not a new version even. It's a rethink. It's a new ideology of the protocol. DCOM is no longer needed. The protocol doesn't need that technology, but for us to be able to use it, this protocol can run on Linux and other operating systems, including PLCs. So an OPC server can be installed together with a PLC. This protocol is more open source. There is documentation supplied with it, and there are a lot of free and open clients that have already been developed. In terms of authentication, this protocol offers the server developer to implement their own authentication. The protocol has a mechanism, but the authentication itself, the kernel of the authentication, should be deployed, should be implemented by the server author. Moving on, OPC UA. The standard is free, while in case of OPC DA, you have to pay for the description of the standard, or you have to know how to Google well. In terms of other differences, because there is no description of the standard, there is no, and because it's a DCOM related, there is no Wireshark dissector, and it also uses 135 TCP as the assigned port. And C headers are also freely available. Going back to ports, a dynamically assigned port can also be assigned to OPCDA. OPC UA, like I said, the standard description is free. The reference implementation from the developers is also available on GitHub. You can find it from OPC Foundation there. And now let's talk about clients. The clients that are necessary to use the protocol. For OPCDA, you have to search for clients. On the slide, you can see 2 clients that are conditionally free. For OPC UA, there is a great variety of clients. You can see some of them on the slide, but actually you can find many more on GitHub. Okay, now let's take a look at what the OPC server actually is. Now you can see a SCADA system on the screen. It's a rapid SCADA. It's the same system that I shared with you yesterday. This SCADA system works via an OPC server. It's connected to an OPC server that you can see. In the OPC server, we have several variables that are read from the PLC. In this column, you can see the identifiers of the variables, and then all clients will work with those names. These names are necessary. As you can tell, in the next column, these variables are described in the PLC terminology. Let's take input valve variable. This is a memory region from which the value and the type of this variable are read, and also the address. As you can see, the address is 00. That means exit 0 and 0 bit is read. It is clear that this kind of addressing is not very handy. Input valve is a name that is much easier to handle. Right now, the value is false. It means that the valve itself is closed, and the so-called quality. Quality is the value that has that is assigned to every variable, and it shows you how much we can trust this value. Good means that the variable is updated and read successfully and on a regular basis, and we can trust this value. If there is no connection with the controller, the quality would say bad, and it means that there is no communication with the controller and we're not receiving any inputs from the controller. Now, let's see how we can connect to this OPC server. Well, I'll show you at first how to do this using perhaps the most popular OPC client, the OPC Explorer. It is capable of scanning local networks and it can find OPC servers. So this one has already found our server. It's called SCADA, and it's trying to scan it to understand which OPC servers are running. It will take a couple of seconds. And by the way, if you have any questions, please send them to the chat. Since this server, start again. Since the client can search for servers only in the local environment, we will try to connect to the OPC server, which is located in a different network. We'll take a ready-made utility to try to establish such a connection. We can see that, unfortunately, this client could not connect to this remote server. We can add our server manually, but you can see that it requires not just the IP address, but also the name of the server. But we don't know that name yet. So what we're going to do, we'll use the DOPC-DA client. It's a different piece of software. I'll press here, connect to server. I will enter the IP address of the server. If you are hacking a factory, then you are supposed to already have it. And let's wait for a connection. And when the connection is established, we will see the name of this OPC server. We'll take this name, and then we will be able to connect to it. We have to do this, because if you read the description of the standard, if you read the API that is used to establish a connection, you will understand that the standard says that it can be used for several servers at the same time. So the name of this server is the mandatory parameter for us to know, so that we can find it on the network, and we can't do it using the host name, so I'm going to use the IP address. It will take some time. The OPC client has to connect, and it will need time also to do reading. And Since you and I, we all see that it's not working perfectly well, although we did a test before the presentation. Anyway, if this live demo fails, then later today, during our second hour, I will come back to this presentation and give it another attempt. Well, yeah, unfortunately, we timed out on the connection. Well, those things happen. Because well, very few things in life are perfect. And we have just been a witness to this dictum. Again, I will still try to show you how to connect to a server and how to change the variables there. Anyway, so we have discussed how to hack the SCADA nodes. As a hacker, as a pen tester, you intrude the corporate networks of a factory or an enterprise, and you gain access to the process network. And then via the OPC server or another gateway, you will get inside. In the OPC server, you can either use some regular vulnerabilities, as I'm showing now on the screen. The RDP brute force or exploitation of a well-known vulnerability MS08067, which is a consequence of regular updates, or you can abuse the external service exploitation. You can also make use of the vulnerabilities of the server if you found them. You can use them, and on this diagram you can see that a denial of service can be arranged with those vulnerabilities, or you can have a alleged connection to the OPC server and use this connection and write variables which will spoof data, real industrial data. Well, once you've penetrated the OPC server, you get access to the PLC. And you could do lots of interesting things with the PLC. You can have a lot of fun. In this case, we managed to cause a denial of service. We also managed to establish a different, to install a different firmware, a different version of it. Even the software that we coded ourselves with the backdoors and everything, and we also managed to interfere with the PLC program itself. We managed to modify it. So a denial of service attack would have caused economic losses and idle time. A program modification, software modification, could potentially lead to more severe implications. Apart from economic losses and idle time, we could have damaged equipment. We could have caused a fault, a functional fault in the SCADA components. And in this case, we also had the so-called protocol converters, which are converting the PLC protocol into the protocol that can be understood by the SCADA system, PLC to SCADA. So we tried to understand whether there were any capabilities for us to flash it with malicious firmware or to reconfigure. And actually, it turns out that yes, it is possible. And if you can reconfigure, then this can also cause a failure of SCADA or ICS, industrial control system components. Then let's focus on the typical security misconfigurations. This is what we encounter in real life industrial control systems. We'll start with the classics of pen tests, default credentials or passwords, the default passwords from the vendor or passwords that is used by the integrator everywhere on all their projects, unencrypted protocols. And here I mean both non-industrial and industrial protocols, HTTP and others. Also, for the software in those systems, it is typical that they would start with some redundant privileges. If you're exploiting a vulnerability of the software and you gain an ability to execute arbitrary code, you will be doing this with a lot of authorization. Apart from default passwords, we also find simple passwords. It's a string that starts with the facility name and ends with some small string or some number. Those passwords can be found quite easily. Or you can also see passwords of the like of OPC, double column OPC. Often, the firmware is not updated. Installing updates means that your process must not be interrupted by those updates. And it means that your process must be very resilient. Often, updates are not possible during operational time, and the firmware is updated during the maintenance window when your facility stops once a year for maintenance of the main equipment. This is also the time that is used to install software updates. And this applies to all kinds of software. OS, firmware, doesn't matter. And firmware actually, it's very rare that you see firmware updated. Usually you would have to call special experts, specialists, who have the skills, who know how to do it. Usually there is no security software installed, or the security software settings are either disabled or they are brought to the minimum. If there is an antivirus, most likely it's not running in real time. Most likely it's coming online only if there is a USB stick inserted into the device or something. Again, this is critical infrastructure and nobody wants to risk losing the machine or a server through misfunctioning of some software. Or proper functioning but excessive functioning of the software. Another thing that happens is that many software vendors do not guarantee compatibility of their software with the pre-installed solutions, which is yet another barrier that is detrimental to security software installations. L2 protocols without authentication is yet another often case. You enter a network, you scan it, and all the equipment that supports L2 protocols will respond to you immediately, and that means that right away you can reconfigure this equipment. All the network settings can be reconfigured, and all operators and all the machines that are receiving the data via the network, they will stop operating. Profinet DCP is an example of such a protocol. It's developed by Siemens. And what also happens quite often, auto login is enabled at the operator stations or workstations. This is because of how operators organize their work. Auto login enables entry into the machine when it's disabled. You will go inside, you can enter the system, open the kiosk mode. And this is a machine that will offer just the kiosk, but there is no access to the operating system. It is clear and simple, but if you hack the machine differently, you'll be able to find the auto login credentials. And now, let's say a few words about the problems of the industrial protocols and of the industrial equipment. The most trivial of those problems is that many industrial protocols are vulnerable to replay attacks. You can record the network traffic, and you can inject it back into the system and cause the same actions to be repeated. Historically, these are the very first days of the attacks on industrial equipment. The PLC command would be sent to a PLC to stop. It would stop. The traffic would be recorded. The process would be disengaged. The traffic would be recorded, and then this is your vulnerability right there. You don't have to do anything extra. You just take the script of several kilobytes and repeat it over and over again. Another thing, again, that we find quite often is the lack of authentication in the protocols. Even if there is some kind of authentication in there, it wouldn't be used in practice. Lack of encryption, another challenge. I believe that I don't see much in encryption in network protocols for industrial applications. Sometimes you would find signatures, but even a signature would be an exception to the rule. Besides, it is also possible that developers will decide to use multicast to transfer some data, and this data can be forged. For instance, in the PLC, there is information about the state of the PLC, and then there is information about the command. So if you spoof that data, and which is easy to do, you will cause damage. Also, since in this area, security is still something new for many vendors. Even today, you can send random data to some network port and you can crash the protocol processor because of some unexpected error, and thus causing the failure of the PLC. And the same about Nmap, you can scan the device, and you can scan it so thoroughly that it will crash. This is what we see in practice. So you have to be very careful when using Nmap. Now let's turn to the tools that are available today for SCADA or ICS hacking. The variety is not very big, but there is choice. In Metasploit, there are several modules. You can use Metasploit, and it was done actually to hack our stand at the previous hack days. And during this conference, you can also try to use Metasploit to hack the assets. Then there is the industrial exploitation framework, which has several peculiar modules, like there is a module to stop the Siemens PLC, the 7300, 7400 series PLC, and it is also the PLC on which our test bench is running. And there is also the awesome industrial control system security set from which you can learn about some custom scripts. And this is not an exhaustive list. As a matter of fact, if you set your mind to it and do the search, you will be able to find many more solutions. When we were preparing the workshop, we were collecting feedback, your feedback. We asked you to tell us what you find most interesting and what you would like to hear during the presentations. What would you like to learn? We were surprised when we received one such request, and the request said, how do I know that I'm inside an ICS? And I think that this question is caused by the fact that very often during various challenges, various competitions, there is a task of intruding a factory and stopping at a particular frontier. So when you're already inside and you see some machines with documentation, and maybe you have the ICS documentation for the factory documentation, you see some routes there, then the task of hacking to the OT network is trivial. For, well, you know, SCADA equipment, there are only that many vendors. Some of them are extremely popular, and these are the names that we find very often in our practice. If you find some piece of equipment in your factory from that vendor, if you see a web interface or in the traffic, you will see MAC addresses that are associated with those vendors, then with a good probability you can say that it means you can say that you have gone as far as the process line, the equipment of the factory. However, there are some vendors that specialize not just in industrial equipment like Siemens, they also make household appliances. So you have to be aware of that. If you have access to L2 traffic, you can, well, that is to say, if you have access to traffic, you can also scan it for L2 protocols like Profinet or PowerLink. In practical terms, these are the protocols and the ports that are very popular in industrial control systems. If you encounter such a port or if you find such a protocol name, there is good probability again to claim that you hacked until the OT network. On the slide, there is also a link to the list of protocol names and ports. So, okay, now we know how to hack a SCADA system. We know how to do it technically. But the question is, how do we make an impact? How can we cause major economic losses? How do we generate big risks? The problem is not all customers are happy when their process stops or their equipment is damaged. Well, actually, nobody likes that. So you have to be very careful during pen testing and audits of such facilities. So it would be best if you would not be auditing a facility in operation. Do your test during idle time, do your test during maintenance breaks. And every action that you intend to take, you need to coordinate with the facility personnel. Because it's the personnel that's responsible for the operation of the facility, and they're the ones who are interested in making sure that everything runs smoothly. So they will advise you on when is the best time for your tests, and they would not recommend that you do something that might hurt production. A sensible compromise is to use test benches or testing stands. Often, production facilities have them. They consist of real equipment and software, and they are used to test updates or modifications in the firmware. So, different attacks should best be simulated not on the actual equipment in operation, but on those test benches. And since the test equipment is identical to the ones that controls the production facility, I'm sure you will be able to come to an agreement with your customer that the attacks that were successful on your test bench would be considered to be a successful attack and a performance of the contract. Okay, let's review what we learned today. I hope that now you have a better understanding of how to approach an ICS. If this is your assignment, first you have to find a way into the process network, a technology network. Maybe you will do it via some kind of gateway, like the OPC server. Once you are inside, you need to be very responsible in all your actions. Don't do a pen test on the real facility. Use a test bench during a maintenance window. Use virtual machines of the SCADA systems. And during this project, your main objective is to gain control over the production process, because this is what is that's what the customer is interested in. Your target is the PLC. We know it's the PLC that does all the work and that controls everything. Another good target is the SCADA system. As an operator, if you assume the role of operator, you can also inflict a lot of damage, especially if operators can control the production process. You should also pay attention to industrial protocols that are used there, because you may find a lot of ready-made utilities, and by modifying traffic, you will be able to achieve your goals. And last but not least, as they say, find something for yourself and have fun. I hope that everyone who's been listening to this presentation are enjoying their work. And for everything that we learned during this chapter, I wanted to thank Ivan Kornakov. He's our ICS expert, our security expert, and he's the electricity expert. And it is with the help of this guy that today I managed to make a presentation of how to hack plants and factories. This guy knows everything about it. And since we still have some time left, I will probably stop here and ask if there are any questions. But remember that I'll be back at 7 p.m. Moscow time. And during that next session, we will look into the PLC. But thank you very much for your attention. Thank you, Vyacheslav. Thank you, and enjoy the day, and we'll be happy to see you back at 7 p.m. This is an extremely exciting topic, and I'm sure that everyone who's been listening to your presentation have been energized and inspired. Thank you very much, and enjoy the day. Yeah, you too.